then dip them in, I don't know, batter and refry them so they look like regular fries. Like, man, those fries look good. Oh, they're actually sweet potato fries. Okay, so again, reminder, if you haven't already signed up for it, make sure you contact Professor Josh Locklear about the hackathon. Let him know whether you want to do VR or mobile application stuff, and we'll get you onto a good team. That's April 14th from 8 a.m. to 8 p.m. here in the department. It is required for my classes. Otherwise, there's an alternative assignment that will take you 12 hours to complete, which is equivalent to the amount of time you're committing to the hackathon. So you choose your poison. Okay, so let's talk about midterm a little bit. So midterm is going to be this Friday. I mentioned there's going to be 10 questions, short answer and programming. So what I'm going to do here is I'm going to go through the slides up to where we are right now and point out, this is the process I'll go through when I write the exam. I'll point out the things that I think are kind of extra important versus the things that, you maybe don't need to study as much. Something like what is programming and how do we solve problems? These are certainly things that you should know. I don't know if I'd ask this question like directly, like this. Huh? Yeah, but I don't know if I'd ask this directly on an exam. I might not say list the 3 ways that humans solve problems or something. I might not say that on an exam. You should understand it because it might be incorporated into another question, but I probably wouldn't ask it to you directly. I could ask you questions about the CPU more from the perspective of the CPU is kind of a collection of magic tricks, and this is really related to this idea of the 3 kinds of programming languages: machine language, low level, and high level. So making that connection between a low level language and how the CPU has individual type magic tricks that it understands. There could be something related to that. 2 kinds of programming languages: interpreted versus compiled. I would say lower priority, but possibly I could ask something along those lines. It would, maybe comparing the 2, or interpreted languages tend to be slower compared to compiled languages. But I maybe wouldn't ask that question. It's possible, I guess, in this vein, I might talk about Python more specifically and say, what makes Python kind of an interpreted and loosely typed language. So one of these next slides, we talk about loosely typed stuff somewhere. Yeah, here. So 2 types of programming languages: loosely typed and strongly typed. So Python does not require us to define the kinds of values we're going to store in variables. Python is also interpreted. Which means that at runtime, it's being interpreted on the fly. So it tends to be a little bit slower, but it also tends to be, by most measurements, a little bit easier to program in because you're not having to learn as much stuff up front. If you're writing in a language like C or C++ or Java or C#, when you create a variable, you have to say, this is the kind of value I intend to store in that variable. You probably go through that same mindset in any language you're working with. But in those languages, they require you to actually say the word, that this is going to be for holding an int or a string or a char, that kind of thing. All right. Possibly asking what a compiler is, but I would have to be hunting for an extra question because I'm going to probably gear the questions more towards the world of Python, since we've been in that for a couple of weeks now. And since Python's an interpreted language versus a compiled language, I probably wouldn't ask that kind of question because, figure that the exam is going to maybe be half of more of the kind of the historical stuff, the stuff we spent the first, 5 weeks on or 4 weeks on, whatever it was. And then the other half was going to be more of the stuff we've done the last several weeks, the Python-y stuff. something like that. It might even be 6 Python for older stuff. So the older stuff was really the foundation that we're building on top of, but the Python is our applied things that we're really moving towards, but the other stuff is important. Again, this is important stuff to understand how these languages work, but I probably wouldn't ask something very specific about a slide like this that is comparing compiled to interpreted languages. Again, it would be in the light of like a Python. I probably wouldn't ask something about when we use assembly today. It's an interesting concept. It's interesting to think about when you want to talk directly to the CPU, but probably won't make it onto the exam. Domain-specific versus general-purpose language probably would not make it onto the exam. Procedural versus object-oriented, possibly. But since we're just starting to talk about object-oriented stuff, it might not make it on this exam. Definitely be represented on the last one. Maybe not as a direct question, but this is really that slide where we talked about the procedural telephone versus the object-oriented telephone. Object-oriented one looks like a phone, where the procedural one looks like the big pile of wires. I would call this a possibility, but I'd have to be hunting for a filler question, because when I go through and make the exam, I got to think about how long should this take you to solve, and I have 10 questions to work with that. So depending on the programming questions I have on there, I might need to have a couple of short questions that don't take as long or something like that. Same thing, loosely typed versus strongly typed. If I asked something about this, it would be in the context of Python, where Python is a loosely typed language where we can just create variables on the fly. You just make a variable and put whatever you want in it. Memory cost stuff won't be on there. I will probably have a conversion question on there, whether you convert between, I don't know if I would do a speed conversion. So this was our speed conversion or size conversion type stuff. It would be fair game, but I would say it's significantly more likely I would ask you to convert from one base to another base, like maybe convert from base 10 to base 16, something like that, or octal to binary, that type of thing. But I would expect at least one conversion question. If I need a filler, I might even put a second one. Maybe I'll have the two patterns, one that goes to from decimal to some base, and another one that goes from a base to some decimal, since those are two separate kind of patterns. But those should be free points. That should be a free 20 points if there's two of them on there. So make sure that you can do that. I doubt I would have a question that's doing the conversion on speeds. It's important, especially that 1024 thing, that there's 1024 bytes and 1 kilobyte and so on and so forth, but probably won't make the exam. This slide, it's more of important from a historical perspective, but I won't ask you, certainly won't ask you questions like comparing and contrasting these languages. This is more of that building the foundation thing that's important for us to kind of know what's on top of things, but I don't really want you spending time memorizing this stuff for an exam. So, yeah, I mean, I would say outside of maybe something dealing with pointers, when we kind of talked about passing stuff by address versus passing stuff by value. Pretty much just focus on things that involve Python. Right? Not that this isn't important. It's just not something I'm going to necessarily want to test you on. Right? Because I really, and remember again, I'll remind you that my policy is that if you do better on the final exam than you do in your midterm, I'll replace your midterm exam score with whatever you get on the final. So so first of all, you can't screw your grade with this one test. It might look bad for a while until you replace it, but I'm really going to focus on getting questions on this test that allow me as well as yourself to assess where you are based on where you should be in terms of understanding. And from the programming questions, I mean, you're probably going to have several people who are going to get in the 60s or 70s, depending on how much they've gotten into the programming stuff, how much it's clicked up to this point. Because that's something it does take some time to click, and that's why I have that get out of jail free card thing with the do better on the final, and we'll fix it. But many of you will find that for a majority of the test, or for half the test, let's say, you'll do fine. Most of that's kind of memorization or just conceptual stuff. But then you'll kind of really see on the programming stuff where you are relative to where you probably should be. And then you'll know what you need to work on from there. And then I'll also know kind of where the class is as a whole. If the class as a whole bombs the programming stuff, that means we probably need to slow down or spend some more time on some of the concepts. If you have 2/3 of the class that kind of got through it, beat up but relatively unscathed, then 1/3 that really is just weak, that allows me to then focus on those folks and say, okay, well, what can we do through homework assignments and help them get their skills up so that they can do better on the final? Okay. My ideal world is everybody gets A's, but you got to earn it. I like the misery, but I like I want to see you suffer as you go through the class. In the end, I want you to be successful. All right. So don't spend time trying to memorize this lineage of programming languages or something like that. It's important, but we're going to be focusing on Python stuff in here. Next semester, we're going to be focusing on Java and Android stuff. Okay. So similar with this kind of stuff, I'm probably not going to ask you questions that really get into specifics from these slides. So I wouldn't worry about anything from this slide. You should kind of know about arrays and lists because we've referenced them from the Python perspective. Similarly, we've kind of referenced structs from the dictionary perspective in Python. I probably won't ask a lot of those, because we haven't had a bunch of practice with them. We've kind of more been focusing on string stuff in Python more recently, and just a little bit with lists. But nothing C specific. Certainly the concept of variables is going to be important. There's going to be questions on the exam where I'm going to ask you to read code, which you should be better at doing than you are at writing code right now. So several of you will get to the exam and you will do well on the reading code and tell me what the code does, and then you'll bomb the writing it yourself. And that's very common. It's very common for when you see it, it doesn't look too bad. But if you're asked to write it yourself, you're just not there yet. And that's okay. I expect it. All right, so that's what the purpose of the exam is, as well as to punish you. So memory, variables, understand that concept of having things in a program and having to remember them through multiple lines of the program. This idea of primitive types, this is really just that connection to all of our modern languages, our C-based things. I probably wouldn't ask you anything off of this. This is, again, one of those memorization things that is an important foundation, so that when we get into Python-y stuff and we start thinking about, oh, I have a number, well, how big is that number actually represented under the hood? That might be important in a program where you have to store a really, really, really big number and it doesn't fit or something like that, okay? But don't go memorize that a byte, well, you should know that bytes are 8 bits. If I ask you a question of how many bits are in a byte on the exam, you should know that. I probably won't ask that, but you should know that one. I won't ask you how many bits are in an int or how many bits are in a long or a short, those kind of things, because that's not something we're directly working with. Again, memory cost stuff, that's interesting, but not something I'm going to test you on. Certainly, well, this was us talking about signed versus unsigned numbers. I probably won't ask you a question about signed versus unsigned because in Python we're dealing with just signed numbers, but certainly conversion stuff with binary would be fair game. So something like this, like base 4 to decimal, you should be able to convert from any base to decimal. It doesn't have to be a base with a name. So our bases with names are base 2, base 8, base 10, and base 16, right? That's binary, octal, decimal, hexadecimal. Base 16, Bixby thought that was his name. The Samsung phones have two different, we have the Google Assistant and then we have Bixby. the Samsung crappy assistant. It is interesting when you deal with the different, like, and as well as Siri. Have you seen some of those videos where each one of them is kind of pretty good at certain things, and then some of the other ones suck at it, but none of them do one thing, do everything well. You basically need all of them. It's
usually like that Amazon Alexa was like talking to people, like even though it wasn't like registered as like laughing randomly.
that's the way it should be.
And someone walked in their house and it was like reading off like cemeteries and like funeral homes, and they're like
Reciting Bible verses in reverse.
So like, and then it laughed when I told it to stop, and I was like.
This was yours?
No, so I was
Oh,
reading,
you.
I was
Oh,
reading an article
yeah.
about it, like, this had happened to a lot of people. I think there's like 200 cases, like, it just laughing randomly and like talking, and like
Yeah.
people thought people were in the house and
Yeah.
they were freaking out.
See, we have Amazon Echo Dots all over the house because my wife controls all the lights in the house with these stupid things. So for a couple of years, she had little Post-it notes over all the light switches in the house as our training wheels to not touch the lights, because you use your voice to turn the lights on, right? So then for this last Christmas, I 3D printed her covers to physically cover the switches, because you don't want to touch a light switch. It's just, I mean, light switches are so still now. You know? so you like, she's had this cough and she had bronchitis. She couldn't talk. I had to turn lights on and off for her. Alexa couldn't understand her. She lost her voice. I mean, I'm lazy, but how lazy do you need to be to? I mean, I'm like, you could use a light switch, right? It's like not that big a deal. I mean, it is handy if you're like already in bed and you forgot to turn off a light.
Yeah.
That's handy.
Like, right, standing right there, you're like.
Well, plus, like, if my wife's already asleep and I'm coming to bed late, and so a lot of times she'll turn off the bedroom light instead of turning off all the lights. So if I'm coming in through the living room and I want to turn off the rest of the lights, I try to whisper to Alexa, Alexa, turn off all the lights. Then Alexa turns them off, but then replies like, okay, just shouts through the house. It's like, shut up.
Just laughing.
But that would be really funny. I need to actually find if there's a hack to get Alexa to just start like acting unstable in the house, like randomly just talking to herself. Like you walk into a room and
It's kind of sweet though.
Cause I did this several. How many of you watch Doctor Who? Show Doctor Who. We got like 3 people.
I've seen all of them. I haven't seen it.
Okay, every computer science major should be watching Doctor Who.
I haven't seen it.
What's it on?
BBC.
Okay.
The new Doctor Who's like on season 8 or something. So you guys don't know who the Daleks are?
No, I've seen like 2 episodes and I thought it was great, but I don't.
All right, this is another assignment.
Okay.
You have to don't watch the old Doctor Who's. The old Doctor Who's were interesting in the 70s, but they're too old. The new ones are Doctor Who is, well, it's not that I hate them, just the new ones are a lot better. Watch it on Netflix. Force yourself to get through season 1. By the end, you'll like it, but season 2 on gets a lot better. But in any case, in Doctor Who, there's these kind of really powerful robots called the Daleks. They're just pure evil. And so they go around, they just, like, exterminate. They just say that out of the blue. They just have these one-liners. Well, I mean, they're like little alien guys in it, but they're in like robot suits. But anyway, so they say stuff like that. Well, when I still have my cats, I created there's a thing called an Arduino, which is a programmable micro board. And so I put a speaker on it, and I had a couple of pre-recorded things. And I put it like under, kind of just under our bed where my wife couldn't see it. And I sort of kind of, cats will play with stuff, right? So I kind of sort of trained my big cat to like go and hit the button. Sort of, like you still had to like rely on her randomly doing it. Cats, if you have cats, they don't just listen to what you say. Cats just do whatever the heck they want. Okay, cats are horrible pets. I had them for like 14 years. Yeah, they're just terrible pets. They're not good companions. I think I read there was some research thing I said that if you like died in your house, your cat would eat you within a day. It only gives you that long before your cat just turns on you. The fact that you fed them for years just is meaningless to them. I think dogs, they'll like sit by their owner's side and they'll probably give you a week before they turn on you. Yeah. Okay, but in any case, so we had this button under the bed, and the cat would come and start messing with it. So in the middle of the night, we'd have this thing going on, like, exterminate! Yeah, my wife was not happy about that.
Was that before the light switches, or was that after?
I'm not sure. We've had the light switches, you become like numb to it, so I'm not even sure how long we've had them. We have different themes. We have different color lights in the house, so each bulb can do like 20 different colors. So then she has like themes she'll set up, and you can do like have Alexa play music, and then have the lights change colors. What's the point of that?
Yes.
Yeah. You know how much one of those bulbs is?
Too much.
75.
Yeah, they're like $50 bulbs,
Don't last any longer than regular ones.
and they come in 3-packs when you first get your kit. Here's a pro tip. Did you know that most houses have more than 3 light bulbs in them?
Yeah.
Way more than 3 light bulbs. Like $1,000 in lights. All right, so conversion stuff, and obviously also now Doctor Who questions. So be able to convert from any base to decimal as well as from decimal to a base. There will be at least one question on that on the exam. That's a guaranteed question. You should be able to. It's a free 10 points. So conversion stuff. Certainly functions, I will probably... Now, our last couple assignments, we've written some functions, right? We haven't just put everything in main and had stuff running. Let me open up Atom real quick. Just want to remind myself we've been writing functions, decimal to base. So on the exam, I would probably ask you to write a function that takes in some parameters and does something, but something relatively simple, all right? But you should certainly be able to define a function, give it its name, give it some parameters, and then write the logic in here. You should understand the syntax for functions, because that is one area where I'll be able to give you some partial credit. If I ask you to write a function that does something, and you at least properly define the function and then just write garbage inside of it, I could at least give you a point or two for at least knowing what a function was and being able to write it. All right, so that's this whole def function name, open parenthesis, comma delimited set of parameters, close parenthesis, colon. That's a function. All right. Nothing for C++. I won't ask things related to iOS versus Android. These are, again, interesting things that tell us how we got to where we are today, but not really something I'm testing you on for competency in the class. What's this?
I said you could ask which one was better and why.
I mean, it'd be an interesting question, but there's not a right answer. There probably are wrong answers. For instance, if somebody said, "Oh, I like Android better because it has it has Flash support," that's a wrong answer because it doesn't have Flash support. I mean, personally, I think I like iPhone better, yet I'm an Android user. So, I mean, they're the same crap. Each one has their hang-ups. Each one has their bonuses, and whatever one has the best. I'm big into VR, so I have a Samsung phone because it connects with the best mobile VR, the Samsung Gear. In 2 months, when Oculus Go is out, which is effectively a Samsung Gear that doesn't require a phone, it won't matter what. I'll just use that. Because I'm really lazy. I don't like spending the 8 seconds taking the case off my phone to put it into the... I mean, that's 8 seconds I'll never get back.
Then you have to put it back on.
Yeah.
Oh, so 16 seconds.
That is... No, it's longer to put it back on.
Oh, is it really?
Yeah. Then you got to clean the screen afterwards because you got to clean your screen on both sides.
That's like a minute. Oh.
Yeah,
It probably is. When you add it all up, it's a minute. Yeah, you're not getting that back. When I got things to do, I got to tackle fridges.
Throw through garage walls.
Gotta throw that for
All right. Yeah, so nothing on the history of Apple, Microsoft stuff. This is important information. It really tells us where we got to where we are today, but not something I want to test you on from a competency perspective. All right. Steve Jobs' blood type should obviously be on the exam. I never covered it, but it's on. Nothing about Steve Jobs. Not even his blood type. Not even his blood type. Also important, but won't be on the exam. All right, so this idea of parameter passing. So this goes with that whole thing with functions. Writing a function takes a couple of inputs. Whatever input you pass it, it works with those. So you can write the function once, and then you can reuse it over and over and over again, passing it different inputs. So this idea of passing by value versus passing by reference. I think the example I probably used in class for that top concept was, if you're inviting me to a party, do you hand me your house and tell me to open the door at 8, or do you give me the address of where your house is? You give me the address because houses are heavy, right? So, a house is expensive. You wouldn't hand somebody a house and tell them to open the door at 8. Instead, you give them a little piece of paper that says, come to this address at 8 o'clock, right? That's cheaper. Yet, if somebody asks for a quarter, you probably wouldn't give them a piece of paper that says where they can find a quarter 3 blocks away. You would probably just hand them a quarter if you had one, okay? Or you'd say, who carries metal chunks around with them? Just this dumb money. Why are we still carrying metal chunks around?
It's kind of weird.
You can scratch up your lottery. That's a good point.
Can you use your fingernail for that, or somebody else's glasses?
Someone else's.
Isn't there actually something though? I actually think the metal that's in our coins is worth more than the coins themselves, or at least a couple of the coins. Is it just pennies?
Pennies, I mean, like 8 cents or something.
Yeah, so that's the way to.
That's why they have the.
So you take your money. So it's is a penny worth 8 cents?
Probably, yeah. Me.
Seriously?
That's
You
why-
could have
that's
an
why
eight-
it's-
you could have
it's-
You have an 800% return on. Okay, this is what you do. Okay, wipe out your bank account. Go to the bank, convert it all to pennies.
Oh, dear.
Melt it down. So now you have, what was it? Copper and tin? What's
I don't know.
let's assume it's copper. That's fine.
There's some other stuff.
Melt it down. So now let's say you had $100. Now you have $800 worth of molten metal. Sell the metal. Now you get $800. Convert the $800 back to pennies. Then you just drop out of school, go buy an island. I mean, you just got to do this several times. Yeah, you just all you need is a bucket of pennies and a fire.
That's why they put grooves on the quarters and nickels, is because people kept using their knives to
Chip away the thing.
Yeah.
And newer pennies are made
have
of
that.
mostly of zinc, and then the ones from 1837 and 1857 were made of bronze, which is copper and tin.
Okay, so the newer ones probably are not worth 8 cents. The older ones are worth 8 cents. So you got to convert your bank account to old pennies.
Let's get some of that stuff.
You have to make the bank teller look at the year on every single penny.
Oh, that's a good
Like, this is gonna cut it. I can't melt these down.
No.
You know what happens when you heat zinc? It'll blow up in your face. You can't do that. All right. So parameter passing stuff. How do you go from melting pennies to?
Zinc is $1 a pound.
How many pennies equal a pound?
I don't know.
Probably more than 100.
Yeah, feels like more than 100.
Or
Well, like,
How many-
I thought.
Actually, I don't know.
145 pennies per pound.
No,
Yeah, see, it's not
that's
right.
a losing endeavor.
Less than new pennies.
Yeah, you gotta work with old pennies. Might be hard to get a supply of old pennies.
Pre-1982 was made of different metal.
Yeah, that's what I'm saying. But they're probably working on taking those out of
Bronze is
circuit.
128 per pound, so you're still losing.
Oh, really?
That's what it says.
Inflation.
There you go. They're completely copper.
If you were at the Bitcoin talk a couple weeks ago, I did the conversion for how much money it takes to create $1 million US. It's like $50,000 to make $1 million to produce it. Doesn't make any sense.
Gotta spend money to make money.
You're not making money.
But this is in the most literal sense. Okay, so again, structs versus classes won't be on the exam because this is more of an object-oriented programming language concept where I'm going to start focusing more on the Python stuff. So we have started talking about classes, haven't we? Or have we not done that yet? We maybe haven't done that yet. We have not. So there won't even be anything about classes on this one. Second exam, we'll have plenty on classes. So this one, we've done lists and we've done dictionaries, correct? Yeah. So the extent of functions, lists, and dictionaries are going to be your go-to moves on the, and strings, be your go-to moves on the exam for programming stuff with a pretty heavy emphasis on functions and strings. And then the next guy in line would probably be lists, and dictionaries would probably be last. Because we haven't had as much practice with dictionaries. So I would say a heavy emphasis on functions and strings, with a secondary, much lighter emphasis on lists. So definitely from a programming perspective, review string manipulation stuff. In fact, if you just reviewed string manipulation stuff and just glanced at lists, you'd probably be fine. It's possible I might do something with lists on the program that you have to like read, or if I do something with lists for programs you have to write, it'll just be fill a list with the odd numbers or something like that. You know, really practicing a for loop. So for that, I'm probably mostly going to be looking at, do you know how to use a for loop? And if you use a little bit of a funky syntax for filling the list, I'm going to care less about that. I want to see that you know what a for loop is. Concept of a pointer, that whole pass by address thing, important, might make the exam, but I would probably, in order to ask it directly, I'd have to, I'd need a filler question. This design pattern, if I asked anything about design patterns, it would be this idea of MVC, and I'd have to be looking for a filler question. This is something that really connects to every programming language today. Model view controller, where you have your code in one place, your interface in another place, and your data in another place. I don't anticipate asking a question about it, but if I asked anything about things in this group of slides here, it would be something with MVC, because it's ubiquitous in all of our modern programming stuff. You know, I won't ask anything about Ruby or PHP or really web stuff in general. Again, these things, all these JavaScript libraries, it's important if you start getting into web programming stuff. This is going to be the stuff you use every single day, but not really applicable to what I want to measure your competency in here. Okay, so now as far as Mendix goes, I will probably not ask you any specific questions about Mendix. Mendix might fall into, like if I asked a question about MVC, I might ask it in the context of Mendix, where Mendix, you had your screen where you designed your interface, then you had your micro flows where you kind of wrote your logic, and then you had your data modeler for your storing your database. That is MVC. Okay, so that is their implementation of MVC. MVC is an idea. That it's a good idea to separate those aspects of your application into separate files. Mendix accomplishes that through their view view builder, their data modeler, and their micro flows. So if I did ask a question about Mendix, it would be in the context of MVC, just an idea of that tool. All right, that's the gray stuff. All right, so it's possible I could ask a question about this. So this gets into that Python specific stuff where we talk about Python being a general purpose language. It's an object-oriented language. It's an interpreted language. It's a high-level language. And it's a loosely typed language. Kind of knowing where in the world of programming languages the language we're working with fits. All right, because having that knowledge gives us some insight into what we're going to be dealing with this knowledge. It's general purpose, so we can solve all sorts of problems. It's object-oriented, so we'll be able to, it's a very modern approach to programming. It's interpreted, so it might be a little slower. It's high level, so it should be easier for a human to work with. It's loosely typed. That, again, goes into that whole slower, easier for a human to work with thing. At the, you're trading off convenience of not having to write some extra code, but not having to define what kind of value lives inside of a variable. You're trading that for speed. You're willing to let it be a little bit slower so that you have to type less stuff. All right, so know where Python fits in the world of programming languages. All right, because then again, this kind of leads us into this. Programming as a skill set is what we're really trying to learn here. We're not learning Python. We just have to be using Python as our example language. So you can learn any language. Once you know how to program, you can learn any language very quickly if you know memory, asking questions, and repetition, how to represent those things in that language. Obviously, the indentation aspect of Python, extremely important. Be able to work with the the plus operator being both for concatenation as well as addition. Modulus, so be able to deal with the integer division. This double front slash does the integer division. The percent symbol does the remainder. So be able to work with that. The branching stuff, so if, else ifs, else's. So be able to write, that's how we ask questions. The idea of a Boolean expression, any expression that boils down to a single value of true or false. I might not ask you about Boolean expressions specifically. I might. That would be fair game. But you're going to have to use them in if statements. You're going to have to use them in while loops. Okay, so these are things that you're going to have to show me you know how to work with. All the arithmetic operators, most of which you were already familiar with. You should be able to work with Boolean expressions dealing with those. The logical operators, specifically the ands and the ors for us. I probably won't have you do anything with not or XORs. I won't ask you to write a truth table. I won't even ask you about truth tables, but you should probably understand what the point of a truth table is. Won't ask you about bitwise shift stuff. That's more of how things work under the hood. Here's examples of Boolean expressions. You should be comfortable with these types of things. This is going to be a pretty good tip on the questions that I show you code and ask you, what does this code do? I won't intentionally try to trick you on the code, but I will probably use variable names that are very generic. Don't necessarily let you know exactly what I'm doing. I'll purposely use, A, B, C as variable names. Mm-hmm. So walk through the code and really try to determine what it is actually doing, rather than glancing at it and deciding what you think it's doing. Make sense? One line at a time, maybe keep track of your variables and change them as you're going through there and see what this guy actually does. All right? Different types of loops, be able to work with those. Be able to write functions. I wouldn't ask you a programming question on the test that is at the same level of complexity as the like the conversion stuff, where you're having, 10 lines of code or something. That's more than I'm going to ask you to write on the exam. I'm going to really want you to probably write a loop that does something to a string. That type of stuff, because I want to see you. I really want to measure your mechanics at this point with what should be light problem solving. Some of you might still find that intimidating, but I'm not going to be trying to ask you very complex problem solving questions, because then you'll get so overwhelmed that I won't be able to see your fundamentals. So I want to be able to see that you knew you needed to use a loop, that you knew you needed to build up a string, that you pretty much knew how to build up the string, and if your logic is a little bit out of order, you're going to lose points, but you won't lose massive points. All right? So don't expect the complexity of what I'm asking you to program on the exam to be as hard as what your programming assignments have been. It's possible I could give you program code to read that's at that same level. If I'm asking you to say, what does this do? This is our toolbox. Questions, comments, concerns, bribes? Okay. We will cover some new material that won't be on the exam on Wednesday, but if you do have questions or you do have topics you want me to review on Wednesday, bring them with you. I'll ask you at the very beginning of class, and I'll go over anything you want me to review, and then we'll move on to some of the new stuff that will not be covered on the exam. All right? I will see everybody on Wednesday.